Yeah, so good evening all. We'll be starting within 2 minutes. Let's wait for others also to join and then we can start our session today. Yeah, so I guess we can start. Meanwhile, can you guys please confirm whether am I audible or not? Like you can type it in chat box. Okay, yeah, thank you so much. So let's start with our session today. So good evening once again. I am Diturajan Sujawat. I am currently working as Prime Minister Research Fellow in Department of Earthquake Engineering from IIT Roorkee. This course is currently being tutored by Professor Dilip Kumar Bedia, who is professor in Department of Civil Engineering from IIT Kharagpur. Those who are joining this session for the first time, let me tell you what are the objectives of this session. So we'll be interacting with our learners in this particular session. So we'll be discussing some of the important concepts which will be required to solve your assignment problems. Along with that, we'll be solving some of the sample questions. We'll be solving your doubts which are concerned with this particular NPTEL course. And apart from that, if you are having any non-tech query, let's say if you want to discuss about something which is not related directly to the course, you are feel free to interact. So we'll help you to whatever extent it's possible. So please feel free to interact with us. So let's start with our session. So today's session is also like there will be some questions which will be related to your fundamental concepts of the soil mechanics, and then some of the questions will be there which will be concerned with your shallow foundation. So this is the first question for today. So bearing capacity of the soil strata supporting a footing of size, let's say 3 meter by 3 meter, will not be affected by the presence of the groundwater table if located at a depth of. So if we are talking about the bearing capacity of the soil strata, which is supporting a footing having a size of 3 meter by 3 meter, at what depth, after what depth, the bearing capacity won't be affected. So let's check the answer. Yeah, so the correct answer is 3 meter below the base of the footing. So let's say if you are having a certain soil strata available with us, and this is your footing. So the pressure diagrams which will be assumed to be formed in this type of strata will extend up to a depth of 3 meters. So whatever width will be there, so in your case the footing width is 3 meters, so we will assume that your pressure bulb will also assume to be formed up to a depth of the 3 meters. So yeah, the correct answer is D. So whatever will be the base of the footing, the size of the base of the footing, till that depth we can assume that your bearing capacity will get affected. After that, it won't be affected by the presence of the ground volatility. So if anywhere if the ground water is available, let's say up to this extent, your bearing capacity will get affected. After this depth, you won't see any change in bearing capacity, won't be there. Let's move to question number 2. So consider the following statements associated with the local shear failure. So what is the correct statement which concern with the local shear failure? Failure is sudden with a well-defined ultimate load. This failure occurs in highly compressible soil, or failure is preceded by the large settlement. So which is the correct answer for the local shear failure? Yeah, so let's check the answer. The correct answer is 2 and 3.
सर आप एक बार एक्सप्लेन करेंगे
Yeah,
प्लीज.
yeah, I'm explaining this. One second. Yeah, so in this particular case, if you see, so you are having a certain footing, uh, which is underlain by the soil. And let's say if it is subjected to a certain vertical load, then you will observe there will be slip lines which will get formed, right? And let's say these slip lines are particular the stress lines which has been formed by the applied vertical loads. If these slip lines extend, let's say up to the surface, then we call that as a general shear failure. So in this you are having certain type of load, and usually it occurs for, let's say, for uh, friction angle greater than 29 degree or something. Yeah, and let's say then there's a certain another type of failure. So and then one second, guys. Yeah, and in another type of case where you are having for certain loose soil, yeah, so in that also your slip failure will get formed, but in that particular case you'll be having slip failure lines, but this slip failure lines won't reach to your uh, surface of the ground. Yeah. So I was talking, if this is your particular footing which is there above, and if it's certain subject to vertical load, so in case of your local shear failure, this slip failure lines won't reach to your surface and it will stay intermediate. This usually happen uh, for the loose soils. So in this particular case, there is no failure the exact failure defined. So you don't know the slip lines which are getting formed at what load it will get formed. So it depends on the soil characteristics also. It depends on the orientation of the footing also. So you don't know about that. But yeah, one thing is sure, like this failure usually occurs in the highly compressible soil. So that highly compressible soils usually have the low shear strength. So the slip lines which are getting formed, it won't reach to the surface. It will stop in intermediate only. So if you further see, this footing will get settled because there is not that much resistance available by the soil. So these failures occurs in the highly compressible soil. And yeah, we can see the large settlement also, as I have explained. So in this case, with the applied vertical load, there will be certain settlement in the footing. So among all these three statements, we can see, since there is no defined ultimate load, so you don't know at what load you will observe this particular failure, general shear failure, local shear failure. And also this failure occurs in the highly compressible soil. So in loose soil where you have the low shear strength, and also this failure account for the large settlement in the soil. So among all these three, you will having the two and the three available with you. So yes, the correct option is B, 2 and 3.
Okay, okay, sir. Thank you.
Okay, okay, guys. Any other doubt, guys, if you want to discuss? Okay, if not so, then let's move to our third question. Yeah, now you need to find the minimum bearing capacity of a soil under a given footing occurs when the groundwater table is. So among all these four cases, at what level your groundwater table will affect the minimum bearing capacity?
Sir, I think its answer is option B.
Yeah,
When the groundwater table reaches to the ground level, ground surface, so at that time we have basically minimum less bearing capacity, isn't it, sir?
yeah, yeah. Okay, Sandeep. Yeah. So can be possible. We'll discuss this thing within 2 minutes. So let's other also people. Let's allow other people also to
You are
speak.
muted, sir. You are muted.
Yeah. Sorry. Yeah. So I was saying, yeah, maybe the possible answer, Sandeep. Thank you so much for your response. So we'll look upon that. Let's other people also think on this, and then we'll discuss.
Yeah, yeah, sure, sir.
Okay, Sandeep. Thank you. Yeah. So let's check the answer. Yeah. So correct answer is B, the ground level. So let's look on this. So the corrected pointed out by the Sandeep as well. So let's say this is your yeah. So let's discuss it verbally only. So when we are accounting for the minimum bearing capacity, so usually the availability of the water or let's say the moisture in the soil will basically reduce your shear strength because shear strength is the parameter of your effective stress, and then effective stress further depends on the pore water pressure. So since with the availability of the groundwater table at whatever depth, it will definitely reduce the strength of the soil below that. So among all the four cases, we can see the maximum contribution of the groundwater table will be there when your water table will be available at the ground level, because again at the base of the footing though the groundwater table is there, but above the base of the footing there is certain contribution of the certain extent of the soil which is basically not involving in the contribution of the pore water pressure. And then at the ground level, below the ground surface, you'll be having all the water, your soil is fully saturated, and definitely the effective stress will get decreased. And in the C and D also, uh, in both the cases, since there is some certain extent of the soil which is contributing in increasing the effective stress, because there is no water table is there. So yeah, we can check among all the four options. B is the correct answer because that will majorly contribute in the decrement of your effective stress due to the increment of your pore water pressure. So any doubt in this, guys? Okay, if not so, then let's move to next question. One second. Yeah, so let's look to the next question. Yeah, so usually when we derive the equation for the bearing capacity using that Tarjagi sweep, so the soil wedge which usually form below the footing, in which particular state that wedge we consider as? So whether it is in plastic equilibrium, whether it's in radial shear, you are having the elastic equilibrium, or you are having the linear shear. So let's check the answer. The correct answer is elastic equilibrium. And how we can say this? Because usually the wedge which form the, let's say this is your footing, and if you are applying a certain vertical load, so this wedge which is getting just formed below, So this we assume that as the elastic equilibrium. So let's say whatever load which you have applied, if it's not leading to the formation of your slip lines beyond this extent, so we assume that whatever load which is coming to this wedge part uh, is basically resisting the whatever load which is coming on this, and it is not going into the plastic zone. So let's say if you remove this particular load from this footing, so your soil will again regain its shape before loading. So that's why we call this uh, scenario such that this soil formation, this wedge formation is in the elastic equilibrium. So though in practical case it's not possible, means having the elastic equilibrium means very minimal, but you will be observing that a certain extent of the soil will go to the plastic equilibrium. It's impossible to get 100% of the soil wedge to be in the elastic equilibrium. But usually for deriving the Terzaghi's bearing capacity uh, equations, we assume that this particular wedge which is contributing in resisting the load coming from above, it's is in the elastic equilibrium. So the correct answer is yes, it's C, elastic equilibrium. So let's move to the next question, question number 5. So in this question number 5, you need to evaluate what is the bearing capacity as per the Terzaghi's equation. हेलो 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 हाँ कामिल जी, बढ़िया है, आप कैसे हो? अच्छा, मैं डिपार्टमेंट में ही था। अच्छा अच्छा, नहीं एक्चुअली मेरी वो क्लास चल रही थी तो वहीं पे था मैं। हाँ 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 हाँ। कैसे हैं आप कामिल जी? सुना मैंने पेमेंट आ गया आपका पूरा आज। आ जाती है नो न्यूज़ हमारे पास। हम्म, किस में अमाउंट डाला है क्या आपने?
हाँ 1 रुपया डाल के देखा था मैंने।
मैं चेक करता हूँ।
ये वाला नंबर लगा हुआ है ना आपने इस पे गूगल पे वगैरह पे?
ये आपने मुझे कौन से नंबर पर डायल किया? एक सेकंड, मैं चेक करता हूँ। आपने फ़ोन पे भी किया, गूगल पे भी किया था?
मैंने तो पेटीएम से किया था।
हाँ आए तो है मेरे पास। हाँ कामिल जी, आए है, ट्रांजेक्शन हो गई।
हाँ तो इस पे डाल।
हाँ तो आप एक बार, हाँ इस पे कर सकते हैं ट्रांजेक्शन, कोई दिक्कत नहीं।
ठीक है मैं करता हूँ।
तो कामिल जी टोटल अमाउंट आपको पता है कितना बैठ रहा है?
टोटल नहीं अभी आने का, मैं कल मिलूंगा आपसे। तो असल में इसमें लिमिट है मेरी थोड़ी सी, वो पूरी हो जाएगी।
अच्छा ठीक है, कोई नहीं, आप मुझे कल बता देना जैसा भी रहता है।
ठीक
ठीक,
है मैं करता हूँ।
ठीक है कामिल, ओके ओके।
सर उसका बिल मैंने बना दिया था।
कितने का बनाया बिल आपने?
लगता है बस 2 दिन से मेरे पास आना नहीं हो रहा उधर।
चलो आप आओ, आप आओ,
कल देखूंगा।
आप आओ, मिलते हैं अपन। ठीक है, मुझे कॉल करना कल आकर।
ठीक है सर।
ओके ओके। So let's check the answer. The correct answer is 85.5 kPa. So in this particular case, did you guys get any answer?
So I have a little bit doubt here.
Yes, yes.
Uh, Bearing capacity means what type of bearing capacity, sir? So basically, we have different type of capacities, na? It is
Mm-hmm.
ultimate bearing capacity, net ultimate bearing capacity,
Mm-hmm.
net safe bearing capacity. So which is to be calculated here?
Here we are talking about the ultimate bearing capacity. If usually nothing is mentioned in the question, by default we assume that it's the ultimate bearing capacity. So
Okay, let us assume ultimate bearing
and
capacity.
also yeah, there's one more point here I forgot to mention. Your footing is basically lying on the surface, so you don't have anything. It's not
DF.
the embedded footing. So accordingly, you can reevaluate your calculation.
Okay. B is the width is unit. Unit means one meter,
Mm-hmm.
but we don't have DF. So let us consider as DF as 1 meter.
Yes, yes. Yeah, DF as 0. Yes.
If you consider DF 0, so ultimately this term becomes 0, na?
Yes, yeah.
Gamma into DF into NQ becomes 0.
Yes, yes.
Okay, okay, okay.
Yeah. So let's check the answer. The correct answer is 85.5 kPa. So let me explain this. Yeah. So this particular case is a very simple scenario where you are having a footing lying on the surface, and your soil is basically the cohesive soil, right? So in this scenario, the bearing capacity which you will see, so usually your bearing capacity is given by C and C plus Q and Q plus zero point 0.5 gamma B and gamma, right? So these are your bearing capacity factors, and we'll see that this factor is usually available like whatever the overburden stress which is available. So this Q and Q is basically contributed by that, and then zero point 0.5 gamma B and gamma is the factor which is responsible for contributing from the friction angle of the soil. So usually since your phi is 0, so that means this term will automatically become 0, and your q and q will also become 0 because it's lying on the surface. So only term which will be remaining with the c and c. And for phi equals to 0, your ANSI value is 5.7, right? Yeah, so your ANSI value is 5.7. So the bearing capacity which will come out will be your C, which is your 15 into 5.7, and that will, I think it's 85.5 kg. Let me check. It's 5.7 into 15. Yeah, it's 85.5 kg. So the correct answer is option C, 85.5 kg. So it was straightforward question because both of your factors in the bearing capacity has been cancelled out. So the final remaining answer is C and C, and you just need to plug in the values. And for phi equals to 0, you need to remember your ANSI value is 5.7. So your bearing capacity is 15 into 5.7, 85.5 kb. Moving to question number 6, you need to consider the following statement and need to mark which is the correct statement among both of them. So guys, any answer? Yeah, we yes guys. So any answer? We do have some answer from our learners. It's D. It's A. So it was from previous. Let's check the answer. Yeah. So correct answer is D. Neither one nor two. So let's look to the statement, both of them one by one. So the first statement is the bearing capacity of a footing on a clay does not significantly get altered by the presence of water table. This is not correct because your water ultimately your bearing capacity. Sorry. Give me a sec. Yeah, so it's visible now. So the correct answer is D, neither one nor two, because as you know here, the bearing capacity formula is given by CNC plus Q and Q plus point gamma 5 gamma B and gamma, right? So let's say in a case when your water table will be there, so your both this factor as well as zero point 0.5 gamma B and gamma, so your this gamma will get changed and this Q will get changed due to the availability of the water table. And by physics also, if you see, so the availability of the water will affect your effective stress, and the effective stress basically uh, leads to your reduction in the shear strength, and thus it will lead to your reduction in the bearing capacity. So this statement is wrong. Again, the second statement, the bearing capacity of a footing on saturated clay pi is a function of the size. So as we have seen, so when your bearing capacity, when your footing is resting on the surface, so your this factor will get 0, right? And since your this factor will get okay, it's not there on the surface, but yeah, it's mentioned it's on the saturated clay, so we are assuming your phi will 0, so your this factor will automatically get 0. So in both the terms you can see your bearing capacity is not dependent on your size of the footing, because on B, because only this factor is contributing uh, to your bearing capacity where the size of the footing is involved, and from this we can see anyways due to the phi equals to 0 is making this factor as 0, and that's why your bearing capacity is consist of only these two factors, C and C and Q and Q. So yeah, your bearing capacity is not dependent on this factor, so neither one nor two. Yeah, so the correct answer is D. Any doubt in this, guys? Okay, guys, then let's move to the next question. So you are having two circular fitting which are of diameter d1 and d2, and they are resting on the surface, sorry, of a pure cohesive soil. What is the ratio of the d1 and d2? I think the question is incomplete here. Two circular footings, diameter d1 and d2. Yeah, so there must be some relation with the diameter. So I think they have not given this relation with the diameter. So I think we can skip this question. But yeah, if you want to check this particular part, so two circular fitting resting on the surface of pure cohesive soil, purely cohesive soil. So when we are talking about the purely cohesive soil, so again your only parameter which will contribute is the C and C and A, and since they are also since they are resting on the surface, so C and C will be the only contributing parameter, and then uh, yeah, so this question is bit incomplete, so they must have given some condition. So yeah, we can skip this. Yeah, we can go on this. So how do you define the sensitivity of the soil? So for that you need to be aware with the definition of the sensitivity of the soil. Yeah, so let's check the answer for this. So it's basically the ratio of the unconfined compressive strength of the undisturbed soil of that soil in the demolded state. Yeah, so Soban and Delhi, yeah, the answers are correct. So the correct answer is option B. So usually sensitivity basically refers to uh, like how much strength is available when your soil is undisturbed, and when the soil is, let's say, get disturbed when you take the core out, or let's say when you uh, change the initial state of the soil in which it was available in the ground. So due to that there is a change in the strength, and how much strength gets changed, it is defined with the help of the sensitivity. And when we are talking about the strength, we are basically talking about the unconfined compressive strength. So for that you need to perform the unconfined compressive test of the soil, and where you won't be having any lateral support to your soil core, and that at that level whatever compressive force you will apply, and then there will be a certain failure of your soil mold, and this basically lead to your certain level of strength which we know as the unconfined compressive strength of the soil. So the correct answer is yes, option B. Moving to question number 8. You are having a sample of saturated cohesion soil which is tested in the drain triaxial test compression test. We showed an angle of internal friction 30 degree. Your diametric stress has been given to you. Uh, Sorry, you need to calculate the diametric stress, and the confining pressure is given to you, which is the 200 kP. So the internal friction of the soil is 30 degree, and yeah, you need to calculate for how much is your diametric stress. So let's check the answer. So correct answer is yes, B is 400. Yeah. So the characteristics when it's tested with the, so usually the ratio is given by sigma 1 by sigma 3, 1 minus sine phi by 1 plus sine phi. So whenever you are having a certain soil mold, so you basically applied a normal load and then you are having the confining pressure. So this sigma 1 is known as the your normal force which you are applying, normal stress, and this is your confining stress. So this is denoted by sigma 1, sigma 2. So you have been given with the sigma 3 which is 200 kPa, and you have been given with the internal friction angle which is 1 minus sine 30, 1 plus sine 30, and is totally multiplied with your sigma 3. So sigma 1 is your none other than 1 by 3 into sigma 3 is your, sorry, it's 3, and your sigma 3 is 200 because 1 minus sine 30 is your 1 minus 1 by 2, and then this is your 1 plus 1 by 2. So you have been given with the sigma 1. Yeah. So it's 1 by 2, and then this is 3 by 2. Oh, sorry. So sigma 1 plus sigma 3, I have written this wrong form. So sigma 1 by sigma 3, the relation is given by 1 plus sine by 1 minus sine phi. So your sigma, it's 1 plus 1 by 2, and your 1 minus 1 by 2. So which is your into sigma 3. So it's your 1 by 2, 1 by 2 will get cancelled, and you will be having 3 into sigma 3 which is your 200. So 1 is your 600 kPa. And when you are calculating the sigma diabatic, so sigma diabatic is none other than your sigma 1 minus sigma 3, and sigma diametric is given by 600 minus sigma 3 is given by 200. So here the correct answer is 400 kb. So you just need to have the catch upon this formula and then you can calculate. So the correct answer is yes, option B, 400 kb. Moving to next question. Question number 9. So yeah, in this particular question, you have been asked, like, let's say if you have a volume of voids which is equal to the volume of the solids in the soil mass, then the values of the porosity and the void ratio respectively. Yeah, so let's check the answer. In this, you just need to know the formula of the void ratio and the porosity. So your void ratio is given by volume of voids to the volume of solids, while your porosity is given by volume of voids to total volume. So volume of it has been given that volume of void is equal to the volume of the solids. So definitely your VV by VS is equals to 1, and in this case volume of voids by total volume, the volume of voids, and then the total volume will consist of volume of voids plus volume of solids. So this both quantity are same, so this is 2 times of volume of void, so it's basically your 1 by 2. So your porosity is 0.5 while your void ratio is 1. So the correct answer is A. Yes. So 0.5 and 1. Moving to question number 10. So for straightforward, you just need to know the formulas. Moving to question number 10. If the time required for 50% consolidation of a sample of a clay with a single drainage is 24 hours, then the time required to consolidate the same sample of clay with same degree of consolidation but with double drainage. So you, in one case you are having a single drainage, and another case you are having the double drainage. Then how much time variation will be there for the 50% consolidation? बता कुछ इम्पोर्टेंट? क्या हुआ? अभी तो यार 8 बजे तक तो क्लास ही है। मेरे पास ही पड़ा है। नहीं, वो एक्चुअली मैं ट्रिप से करने का सोचा था, बट फिर हाँ, बट फिर मैं सोच रहा हूँ कि वो थोड़ा बहुत पैसा पड़ा है मेरा PMRF को, तो उसको रिम्बर्स करा दूँगा। तो IRCTC से कराऊँगा फिर, तो उसमें वो ऑफर्स नहीं आते। ना ना, कार्ड वार्ड का नहीं, अभी तक तो नहीं था, ऑफर तो नहीं था। उन पे ही आता है वो, इन पे नहीं आता स्टैंडर्ड वेबसाइट। अभी अर्जेंट है, अर्जेंट है बात में। Okay guys, so let's check the answer. The correct answer is option C. So if you would have seen the formula, so the time required for drainage with the consolidation is given by CVT by H square, where H is the total length of your drainage path and T is your time factor. So, and you see that T time factor is directly proportional to your degree of consolidation. So with the help of this, you can see that your degree of consolidation is directly proportional to your H square. So with the help of this, we can see that. So with a single drainage, so in one case you are having the drainage as H, and in another case you are having the H by 2. So since U is directly proportional to H square, so yeah, and here also your T is inversely proportional to 1 by H square, right? So that means your T1 H1 square is equals to T2 H2 square, right? So if I compare the T1 by T2, so it's your H2 by H2 square by H1 square. So let's say with the single drainage is 24 hours. So if we say the single drainage, we can say there are T1 by T2. So your single drainage will take the whole path H1, and then your H2 is basically is the double drainage. So the total length which will be required for the consolidation for the drainage will be your half H1 by 2, right? So here it will be H1 by 2. So your H2 square will be H1 by 2 whole square. So if I compare this, so your T1 is none other than 1 by 4 times of your, sorry, yeah, so it's 1 by 4, and yeah, your T2 is basically is 24 hours. Yes, so your T1 is 24 by 4, which is 6 hours. So again dividing, your T1 is the case corresponding to your double drainage, and your T2 is case of single drainage, right? So the correct answer is option C, 6 hours. So any doubt in? So you just need to have the this particular relation in the mind. So your TH, your CV. So CV is none other than coefficient of consolidation, T is your time factor, and H is your total length of the drainage path. Moving to question number 11. It's a theoretical question, so you might it's a very preliminary question. We study in the geology as well as in the geotechnical engineering, so you need to give the answer for this soil deposit which is formed by wind. So we know the soil formation has been taken place by the uh, like it's basically the breaking down of your rocks or your other geological material formed by the lava or other tectonic activities. So one of the cases also where your soil deposit has been formed by the wind. So what type of soil deposit it is among all these four? So let's check the answer. The correct answer is C, alluvial soil. So there's nothing rocket science is that it's just a terminology. So whatever soil deposit which is formed by the wind is known as the alluvial soil. Moving to question number 12, water content of the soil can, so among all these four options, which basically resembles water content. This is a nice question. You can also, I like to have a reason from your end. If you are giving a certain option correct, so which will be the correct? So in saturated case, what water content like you consider? So if you check the answer, the correct answer is B. Yes, your water content can be greater than the 100%. So what is that particular case? So usually in the highly plastic clay. So in that particular case, your weight of the water can be greater than the weight of the solids. So we know that the water content is the weight of the water by weight of solids. So in highly plastic clays, your water content can be can water can have weight which is greater than the weight of the solids. So in this particular case, yes, your water content of the soil can be greater than 100%. So what is the correct option? So yeah, B is the correct option, which is your water content of the soil can be greater than 100%. So that's why you should remember that it's not necessary your water content is always less than the 100%. So it can vary from 0 and even greater than 100%. Yeah, of course it can't be negative, but it can have a value greater than 100%. Yeah, so I think that was the last question for today. We can call a day from now, from this moment onwards. But yeah, if you have any doubt and if you want to discuss something, please feel free to discuss, as we can call it a day. Yeah, if not so, then we can end our session today. Again, just a reminder, like you can watch the, if you have some of your colleagues who had not attended this particular session and want to have a look on that, I'll be uploading the recording of this video uh, after this, and you can refer the YouTube channel. The link of the YouTube channel will be shared to you by the NPTEL team. Also, I'll be uploading this particular PDF of this presentation, and you can refer to that. And again, the link of that will be shared to you by the NPTEL team. Yeah. So that's it from my end. Thank you so much for joining. Let's meet on next Tuesday.
Thank you, sir.